Okay, today we will discuss kinematic indeterminacy, and kinematic indeterminacy we know very well that it is degree of freedom of all joints. Here we have three type of structures. First one is frame, which it consists of total 8 number of joints. This is a beam. It consists of 4 number of nodes, 4 number of joints. This is an example of truss. Is consists of 6 number of joints. So kinematic indeterminacy it depends upon the degree of freedom, possible degree of freedom at all joints. So by summation of all degree of freedom at joint 4, 5, 6, 7, 8, we know very well that they are free in atmosphere. Therefore it will have 3 degree of freedom. That's why 15 is that 0 at 1, 0 at 2 and 1 at 3. Therefore 15 plus 1 means 16. Simply here joint, if this is node number 1, if this is node 1, if it is 2, it is 3, it is 4. We know very well that 1 is free to, it will not have any degree of freedom. This it can have only 1. It can have only 1, it can have only 2. So 1 plus 2, it means 4 degree of freedom of all joints they can have. Therefore kinematic indeterminacy of this type of beam, it will have 4. Simply here say this is node 1, say this is 2, this is 3, this is 4, this is 5, this is 6. So out of this total number of 6 nodes, node number 1, it can have only 1 degree. It will not have because this is an example of truss. Therefore degree of freedom per joint, it is not 3. In that case, in that type of structure, the force coming on different elements means in between node 1 and 2, it can be either this type of force or this type of force, means either this tension or compression. That's why degree of freedom per joint in this case it is different. Okay, rotation is not possible over here. Therefore degree of freedom per joint in this case it can be only 2, either delta x or delta y. So this is the first parameter upon which this kinematic indeterminacy depends. Okay, so the degree of freedom per joint of the structure. Second one parameter upon which it depends. Second one parameter, restraint conditions. Restraint condition at joints. Restraint condition at joints. Third one parameter, number of inextensible member. Number of inextensible member. Fourth one, number of internal hinge. Number of internal hinge, it can be of 2 types, either joint or member hinge or member internal hinge. Last one parameter, it is last क्या बताया था मैंने? Release, force release. Yes, force release. So I will discuss one by one. So first of all, Degree of freedom per joint. Degree of freedom per joint. Degree of freedom per joint. So first for a basic क्या है? First basic for two dimensional 2D means planar type of structure. Okay, it has this one. This write you del x, you write del y, write theta. Okay, and about z. Okay, in case of second for three dimensional means three dimensional space, planar and space type of structure, it will have delta x, delta y, delta z and theta x, theta y and theta z. Means total degree of freedom here it is 3 and here it is 6. It is 6. Okay. It is the basic. It is the basic. नोट करके लिखें, नोट करके. ट्रस टाइप ऑफ स्ट्रक्चर, ट्रस elements have either only tension or compression force. Therefore degree of freedom per joint in case of truss it is different. So in case of two dimension, in case of space, in case of two dimension it has only two, delta x and delta y. In case of space it has delta x, delta y and delta z. Means 2 degree of freedom and this has 3 degree of freedom. Clear to everybody? So this is the degree of freedom per joint. So this is the first parameter upon which this kinematic indeterminacy depends. Clear to everybody? If we know this thing, then you can calculate the degree of freedom for this type of structure, this type of truss. What is that? 1 it has 0. Okay. Joint number 2 it can have 2 delta x delta y. It can have delta x 1. Joint number 4 it can have 2 delta x delta y. Joint 5 it can have 2 delta x delta y. It can also have delta x delta y. So number of how many number? 2 1 3 4 5 6 7 8 9. Okay, total degree of indeterminacy, total kinematic indeterminacy of this truss has how much value? 9. Clear? Another parameter is the restraint condition. Restraint condition. So what are restraints? Restraints. Restraints. Another parameter is restraints. Restraints are the provisions. Restraints are the provision by which degree of freedom, means movement of a joint, is protected. What I want to tell you? What are restraints? What are restraints? Restraints are the provisions, arrangements, right? Whose objective is to protect the movement. Okay, say for an example, at joint number 1, what is arrangement? Fixed type of support is there. If it does not have fixed type of support, suppose it is free joint, suppose it is free, then it will have 3 degree of freedom at joint 1. Okay, but when it is fixed, when we are providing the arrangement at joint 1 of type fixed, then what we are doing? We are just restraining the movements. We are just restraining the movements. Clear to everybody? We are just restraining the movement. Therefore, it reduces the kinematic indeterminacy. It reduces since we are restraining the movement, that's why what will be its effect? Its effect will be decrease in kinematic indeterminacy. And what are those? These are the number of supports. Restraints are what? They are number of supports. So right here, restraints, they are number of supports. They are number of supports. We know very well, for fixed restraint will be 3. For hinge it will be 3. For hinge it will be 2, and for roller it will be 1. Okay. In case of किसके? Planar. In case of plane. But in case of space, in case of plane, if fixed is there, fixed type of thing is that fixed support. Yes. Number of supports here ना, यहाँ पे it is fixed, so number of support will be what? Okay, one vertical reaction, okay, horizontal reaction, VA, HA and MA, right? In hinge में, okay, clear to the word? Clear? चाहो तो आप इसको बना भी लो. No, you can write here also. This is meaning. Okay. This is the meaning. Supporting. Horizontal reaction VA, VB, VA, H. Vertical, horizontal, HA and MA. Okay. Here VA and HA. Here only V. In case of plane, in case of space, how many support reaction will be there if fixed support is acting? If fixed support is acting, how many number of support will be there? How many number? Can you tell me? 6. What will be those? ये VA, ये since we are protecting all movements, okay, since we are protecting all movements, means we are protecting this, okay, So the reaction in all three direction. Okay, reaction in all three direction as well as rotation in all, है ना, moment. Right. So if I can write here fx, fy, fz and mx, my, mz means number is how much? 6. Okay. So in place of va you can write it as fy. Here you can write fy. Here you can write fx and mz. It will be more better. Okay. Write fy vertical reaction, horizontal mz. Okay. Same sequence. Here you should write fy. Here you should write fx. In case of hinge, how many? In case of space, think of that. Last row, think of that. How many reaction will be there? In case of space, if hinge is acting, you know very well that hinge is free to rotate. Then that if it is free to rotate, then there will be no any restraint. Okay. So the restraint, number of restraint will be what? 3. What will be those? Fx, Fy, Fz. Get you everybody? So it will be, in case of hinge, it is 3. And what are those? Fx, Fy and Fz. Get you everybody? In case of roller support is what? Roller support is just, है ना, in that रखा हुआ है. It is in place like this. Okay. So the number of support, it is, in case of plane, it is 1. Space, it will be only 1. Fy. Okay. Right here Fy also. नंबर ऑफ रेस्ट्रेंट मीन्स प्रोटेक्शन, केवल वर्टिकल डायरेक्शन में, बाकी सब में मूव कर, केवल नीचे ही है ना. इट कैन मूव इन, इट कैन नॉट मूव इन डाउनवर्ड डायरेक्शन ओनली. इट इज फ्री टू मूव इन एनी डायरेक्शन बिकॉज एट द बॉटम ऑफ दैट जॉइंट रोलर इज देयर. रोलर मीन्स बेरिंग टाइप ऑफ, है ना, व्हील स्मॉल, तो कहीं पर भी घूम सकता है वो. ओके. यहां पे जस्ट लिसन, यहां पे ये हम कोई भी प्रोविजन ये ऐसे रखा है. ओके. ये कहीं से कैसे भी जा सकता है ना. ये तो इट इज ए चॉक लेंथ है इसका. इफ इट इज इन सर्कल फॉर्म, पॉइंट टिप में हो, तो इट कैन रोटेट, इट कैन मूव इन एनी डायरेक्शन, but it cannot move in downward direction, right? So downward direction is protected only. Ready everybody? Clear beta? That's why number of restraint will, in case of space also it will be 1. In case of roller support, both will be same, right? So this is second parameter, number of restraint. What is the meaning of number of restraint? Clear? Clear to everybody? Number of restraint here. What are the number of restraint? Can you tell me? If it is fixed, and they are represented by capital R. If they are represented by capital R, then what will be the value of capital R? 3 here plus 3 here plus 2. Number of restraint, that is 3, 3, 6, 8. Get everybody? Number of restraint, value of number of restraint, it is 8. It is 8. Here number of restraint, here 3 plus 2 plus 1, So R value of R is 3 plus 2 plus 2 plus 1 means 8. Similarly here, restraint 2 plus 1. Okay, so this one is second parameter. I have explained to you. Next one is inextensible member. Any doubt? No, sir. Inextensibility of member. Inextensibility of member. Inextensibility of member. Okay, so let me take this example. Yeah, let me take this one. Frame. Okay, please concentrate. What is inextensibility? Inextensibility means what? My intention, if the load is applied, load can be applied. This is a beam, so transverse load can be applied. Here, wind direction, due to wind velocity, force will take, force, horizontal force will can act through that direction. So, due to application of the load, if this joint is, say this is 1, say this is 2, say this is 3, this is say 4. Okay, since joint 1 is fixed, that's why it is not free to move in any direction. 4 also not free to move. 3 and 2 can move in any direction. Okay, since this is plane, that's why we have only 3 possibilities, 3 options we can have. If the direction of the force is in this direction, from here, okay, then this joint can be shifted to here, right? Suppose this is 2 dash. Okay, due to application of this load. Similarly, this joint 3 dash. Clear? 3 dash. And this angle, what about this angle? This is 90 degree, this is 90 degree. Okay, which type of motion, which type of movement we can permit? Listen carefully. Which type of motion, which type of movement of joint we can permit in structure? Are you getting what I am asking to you? Which type of movement we can permit in structure so that we can use that structure? It is safe, it is not harmful, it is not collapsible. Which type of movement we can permit? We can permit that type of movement which retains the rigidity. Means this beam and this vertical member, the angle whatever it has, 90 degree or 85 degree or whatever, it should not change. It should not change. Get everybody? If I have this type of structure, if I have this type of, if I have this type of structure. Clear? Then due to application of this type of load, we can permit only the movement of joint by which this angle and this angle remains same. Let everybody, this angle and this angle should not change. If that angle means rigidity, if rigidity is changing, then what its meaning? What its meaning? It is going to crack. It is going to crack. होगा नहीं होगा? It's very simple. It's very obvious. If due to the movement, if the angle is going to change, then it means it is going to crack. Get to everybody? So that rigidity we have to maintain. That rigidity we have to maintain. Get to everybody? So if I am making this tangent, so this is vertical, this is vertical. So here that can be the deflected shape. That can be the deflected shape. Look here. This is straight line. If this is a straight line, okay, suppose I am not considering this one force for this type of horizontal type of force. Okay, so it is straight, exactly straight, and here deflected shape I am making this by dotted line. Tangent here, this tangent and this tangent, it is making how much angle? 90 degrees. So the rigidity is maintained here. So the rigidity is maintained here. Here it does not have any rotation. It's okay. Similarly here same thing can be here also. Deflected shape. Okay. How it can be possible? It can be possible by this way. Okay. As so this can be the deflected shape for this type of arrangement of load. Okay. In laboratory, in structural analysis lab, you can observe the deflected shape of various type of structures. Some simple structure we have in laboratory, you can observe, you can notice. Okay. What will be deflected shape? It comes from your experience. Okay. But one thing it should be kept in your mind, that the rigidity should not be disturbed. Connecting at the joint where two members or more than two members are connecting, the angle should be same. Suppose at this joint one member is here, one more member is here, one more member is here, like this. Clear? So the change, deflected shape will be in such a position. Okay, such a position which will, if this value is theta 1, if this value is theta 2, so this is theta 1, this will be theta 2. That is right? It can move in any point, it can be moved in any point, but it will move in such a manner, such a fashion which will retain the same angle between this joint, this member and this member. Okay, this member and this member, that angle can never be changed. Let everybody come to the topic. I am here discussing the inextensibility. Inextensibility means what? I am trying to say, due to application of the force, change of length is zero. Change of length is zero. Suppose I have this member, this element, and I am applying the force of P equals to 100 kilonewton. 100 kilonewton. Okay, definitely it will have some rigidity, some value of Young modulus of elasticity. Since it will have different shape, it can be circular, it can be rectangular. So it will have different moment of inertia I. and the product of these E and I, product of these, what is that? क्या होता है? Product of E and I, it is known as rigidity. It is known as rigidity. How much material is rigid? How much material is rigid? It depends upon the product of both. Depends upon the product of both. This duster, it is comparatively rigid as compared to rubber type of material. Rubber and comparatively rubber is a much more stiffer. Okay, glass much more stiffer. है ना? It cannot be simply not too stable. Okay. So this is about the deflected shape. Come here. अच्छा हाँ ये here. Come here. If before application of that load P, if this length was L, okay, was L, then definitely due to application of this load, this force P, its length will change from L to कितना? How much? L to delta L. If it is axial force, then what will be the value of delta L? What will be its final length will be L plus delta, and what will be the value of delta? It will PL upon A. We know very well. So it's obvious that if forces are acting on the member, axial forces are acting on the member, then its length will change. But if the value of P, if the value of force P is much less as compared to product of this AE, okay, if this value P, value of force P is much less than in comparison to product of AE, then that value can be taken as 0.00001 if it is in that range. If it is 0.001 mm, get everybody, then that can be taken as 0. It is of course not 0. It can never be 0 because we are applying the force. But due to very smaller value, it can be assumed as a 0. It can be assumed as a 0. Okay, so if the member are assumed as inextensible, means due to application of load, if its length is not changing, then what will be the effect in kinematic indeterminacy? That I want to discuss. That I want to discuss with you. That everybody? Here, look joint number this, joint number 2, 3. Joint number 2 can have this moment. This moment will be represented by, कैसे लिखूं मैं? If this coordinate is, if I am following this coordinate, x, if this is y, if this is z, okay, then this moment is what? Joint 2 has been moved from 2 to 2 dash, and moment is this one, horizontal. क्या लिखा जाए इसको? डेल्टा 2x. Is it clear? And this one moment is what? Delta 2y. Okay. Similarly, this moment, what I should write? Delta 3y. And what I should write for that? Delta 3x. Clear to everybody? Similarly, here rotation, okay, rotation in x direction, rotation in z direction, theta z, here theta z, theta इसको लिखे हम क्या? 2z, है ना? सेकेंड ज्वाइंट का z के लंब, and okay, so total degree of freedom, so total degree of freedom, total degree of freedom means kinematic indeterminacy. Ki means dk. Kitna? How much? It has 3 plus 3 at 2, 3 at 3 means it has 6. 0 for 1, 0 for 4. It has 6. Okay. And what are those? What are those degrees of freedom? These are simply delta 2x, they are delta 2y, theta 2z. Okay. At 2 and at 3, delta 3x, delta 3y and theta. Right? Look here. Come to the topic. Inextensibility. If members' lengths are not going to change, if member length is not going to change, then this one length, this one length and this one length, it will have the same value. It will have the same value. Similarly, this one length, listen, look here, this one length and this one inclined deflected length, this one vertical length and this one deflected length, both will have the same value. Similarly, this one vertical distance and this one deflected distance, both will have the same value. And if this type of thing is that, then is it possible? क्या यही होगा? Okay. And since we know very well that rigidity at 2 and 3, it should not be changed, therefore rotation will also be at same joint number 2 and 3, it should also be, it will have the same, therefore rotation will also be same. This delta y, vertical deflection at node 2, vertical movement at node 2, both are what? Same value. Both have same value. This one, both have same value. Horizontal displacement, this one and this one, both will have same value. Clear to everybody? Therefore, its effect is what? It affects is what? It reduces the kinematic indeterminacy. Clear to everybody? If we want to calculate the degree of freedom, total degree of freedom, then how many degree of freedom I have to calculate? Only 3 in place of 6. In place of 6, we have to calculate only 3. If the members are extensible, means if we apply the load and length of member is going to change, okay, so the length of going to change, then I need to calculate all these 6, because then this value and this value, it will not be same. It may have different value. Clear? If members are extensible, means due to application of load, if they are going to change, then this one value, this one vertical deflection, this one vertical deflection may have different value. Clear? This one value, it may have different. Clear? So, finally we have only 3 degree of freedom. So, in short, therefore we can say, therefore we can say that, you write, we can say that inextensibility of member, you write, inextensibility of member reduces the kinematic indeterminacy. It reduces the kinematic, you write here, therefore it reduces the kinematic indeterminacy. It reduces the kinematic indeterminacy. By which value? By what values? कितनी? How much? How much? It is exactly same as the number of member. How many number of members are there? 1, 2, 3. 3 members are there. Okay. So if inextensibility is there, then it's how much indeterminacy can be eliminated? If inextensibility is considered, maximum 3. Okay, if all 3 members are supposed to be inextensible, then its kinematic indeterminacy will be released by number of members. Okay, so आपने लिख लिया और नीचे ये भी लिखा है, it will be decreased by the number of members. It will be decreased by the number of members. Number of members which are inextensible. Which are inextensible. Let everybody. Which are inextensible. Right. Right is represent this one. This is R, capital R. This in number of inextensible member. Okay. Next one is internal hinge. Force release. Okay, I will discuss these two in next class. Okay, after completing these 4 and 5, I will derive the expression for calculation of kinematic indeterminacy. Right, everybody? After discussing all 5, I can derive a expression. Okay, of course today we can calculate the value of kinematic indeterminacy for this. We have calculated the kinematic indeterminacy for this. For this we can calculate it. But if internal hinge, this one will act, then what will be that? Okay, so tomorrow we will. Today the remaining part of kinematic indeterminacy is number of effect of internal hinge in a structure, and second one effect of force release in a structure. Okay, so now I am going to start effect of internal hinge. So effect of internal hinge. Effect of internal hinge. You know very well what are internal hinge. Yesterday I have told you that it can be provided in this form, and what is it, how it will in this form. Okay, here. Such type of arrangement can be there for internal hinge. Okay, such type of arrangement, these are internal hinge. This is, what are those? Internal hinge. These are the internal hinge. Okay, and I have told you that they can be of 2 types. Member, and it can be of joint. This type of arrangement of internal hinge, they are called as member joint. Member internal. Another category of internal hinge provided in structure may be like this. This one here, that can be the situation. At the joint, all 4 members, at this joint, all 4 members are connecting with a simply pin jointed. Okay, pin jointed members can be there. That can also be possible. this is rigid, but this is the pin jointed type of thing. Okay, so this one it will be treated as internal hinge, but since they are applied at the joint, that's why they are joint internal hinge. They are joint internal hinge. Clear to everybody? And it is different from this hinge. This is also a hinge, but this is a external hinge. This is a external hinge. This is external hinge. They are this arrangement is a provision of hinge, but it is called as internal member hinge, because it has been applied in between the member. That is joint internal hinge, because pin type of arrangement has been provided at the joint. Okay. Now I will discuss one by one what will be the degree of freedom for such type of arrangement. What will be the degree of freedom? Let everybody. If I have this internal hinge, a member, this is a member, say it is joint number 1, joint number 2, joint number 3. At joint 2, member hinge is there. At joint 2, member hinge is there. If we apply the load, then that joint can shift downward. Can shift downward. Therefore, if this joint is at the same point, okay, no. If joint 1 and 3, they are supposed to be stationary, like fixed. If it is here, such type of arrangement, this, just wait. If hinge, if at joint 1 and 3, if at joint 1 and 3 external hinges are there and at 2 internal hinges is there, okay, due to applied load, joint 2 is not able to move in horizontal direction, that cannot be possible. Okay, it can move in downward direction. Suppose rotation, this type of thing is that, okay, pin type of arrangement is here, then due to application of the load, it will try to move in this form. It will try to move in this form. So it can be the deflected shape. Now this joint can be at this location. It can be at that location. Now what are the movements that you have to notice? First one movement is horizontal movement for joint number 2. This is another is vertical movement. This one. Okay. Another movement. Joint one movement, vertical movement, it will be same. If it is known, then that will also be known. Okay, so there is no need to write 2 times. 1 degree of one movement is that, another movement is this one. Okay, another movement is here. It is a straight line. It is a straight member, but here it is not 1, 2 dash is not a straight. Here rotation is there. Say it is θ1. Here in that side also rotation is there. So total movements and movements are what? Degree of freedom. How many movements are there? 4. Okay. 2 rotation, 1 is this linear, another is vertical. So total number of movements are 4. Due to I am considering only the degree of freedom in this at internal hinge only at the internal. What is here I am not bothering that. I am concentrating only effect of internal hinge due to member hinge at joint number 2. Okay, that can be the possibility. Like simply this, है ना, बिल्कुल exactly straight application of the load. This one, है ना, that can be possible. If this situation is that, then what are the movement that we have noticed? Get everybody? This one horizontal for joint number 2, node number 2. This one is vertical movement, and that member will be inclined by some angle. Say theta 1, say for that angle say theta 2. So 2 rotations for individual member, this one, and one is this and this. So total number of degree of freedom 4. Okay, that case has been taken for 2 dimensional. It is the case of 2 dimension. If 2 dimension, if that member hinge is provided in 2 dimensions, then total degree of freedom is 4. Total degree of freedom is 4. And when this is for plane, and if in 3 dimensions, then we will have some additional degrees of freedom. It will be 9. It will be 9. Okay, what are those? Think of that. I will not discuss here. What are those? What can be those? That can be understood by your own. Get everybody? It will be 9 in place of 4. Okay. So that type of thing is only for member hinge. And you know very well what will be its effect in calculation of kinematic indeterminacy. What will be its effect? Effect will be increase the kinematic indeterminacy. It will increase the kinematic indeterminacy. Why it will increase? Because degree of movement, number of movement had been increased by 4 in case of plane, 9 in case of space. Okay. Add on. Effect is add on. Consider for this case. If it is joint hinge is there. Joint internal hinge is there. If joint internal hinge is there. Okay. Suppose I am considering this type of situation. And internal hinge has been provided. Internal joint hinge has been provided here. Okay. Internal has been provided at that point. Okay. So due to application of load, how many members are connecting at that joint? How many members are connecting at that joint? Number of members. Here number of members are connecting. यहाँ पे number of members connecting to the joint. Say it is M. Here in our case it is 3. No, it is 4. In our case it is 4. If okay, due to application of load, it can be deflect, it can be deflected in this manner. It can be deflected. Let me first make the deflected shape. Okay. So this dotted line, these lines have been shown for the deflected thing. If we will apply the load, apply the load means इसको compress करें. Okay. If the members, length of members are inextensible, are not changing, or if the lengths are changing, then it is in very small length, then they will deflect in this manner. They will deflect in this manner. Got everybody? Therefore, degree of freedom, what will be the additional degree of freedom? What will be the additional movement in this figure, in this joint, at that joint, that we have to note. Here, what we did, we have calculated, we notice the movement, two linear, two rotational. Here only rotational. Here only rotational type of thing can be there. Get everybody? Rotational type of thing can be possible. So to calculate, to measure the angle, at least one should be one vertical leg should be considered as the reference line. Any one of them can be treated as a reference line. Anyone can be treated as a reference line. Got everybody? So with that, so according to that, with that reference line, suppose this is reference line, so from that reference line, this is the rotation. From here, this one is rotation, and that one is rotation. So how many? 1, 2, 3. Okay. We have to measure the degree of freedom. Degree of freedom for joint type of thing will be measured with one reference line, with one reference leg. Therefore its degree of freedom will be, suppose this is 1, this is 2, this is 3. So total degree of freedom, it will be m minus 1. It will be m minus 1. Total degree of freedom. And what will be those? What are those? These are the angles, rotational. Get everybody? In joint type of internal hinge, we will measure the angle, we can measure the angle with reference to any one leg, and in doing that procedure, total degree of freedom, it will be all rotational and its value will be total number of member minus 1. Say it is m dash, suppose say it is m dash, not m, it is m dash, so m dash minus 1. Okay, it is in case of plane, and similarly degree of freedom will be 3 times of m dash minus 1 in case of space, means 3D. In case of space, it will be 3 times of m dash minus 1, and in case of plane, it is only m dash minus 1. That you have to keep in your mind. This one thing and this one thing. That you have to keep in your mind. That you have to keep in your mind. Suppose I have this type of beam. What will be its kinematic indeterminacy? Zero degree of freedom here. 1 is here, and how many is? 4. Got everybody? So degree of freedom 0 here, 1 here, 4 here, 1 here. So total degree of freedom is 6. This is the individual degree of freedom at the joint, and it is total. Got everybody? Similarly, if I have I have this type of thing, if I have this type of structure, suppose I have this type of structure, what will be its kinematic indeterminacy? It is frame. Okay, it is frame. So since it is frame, so every joint will have 3 number of degree of freedom, 3 number of degree of freedom. So total number of joint here, how many? Joint is 1, 2, 3, 4, 5, 6, 7, 8. Okay, total number of degree of freedom due to all joints, total degree of freedom, it is how much? 8 into 3, considering all. Okay, minus restraint has to be has to be subtracted. So subtraction will be 3 plus 3 plus 2. That everybody? Subtraction, number of restraints has to be subtracted. That everybody? 3 here and 2 here. So 3 plus 3 plus 2. That everybody? Now, since joint internal hinge has been provided at that joint, therefore additional degree of freedom has to be added. How much? M minus 1. Here m dash, value of m dash is how much? 1, 2, 3, 4. 4. Yeah, everybody? Therefore, additional degree of freedom will be m dash minus 1. M dash minus 1. Therefore, it will be m dash minus 1. And value of m dash is here 4. Okay. So how much will be that value? 24 minus 6 to 8 and plus 4 minus 1 means 3. So it comes to be 19. 19. This is the kinematic indeterminacy. This is the kinematic indeterminacy. Clear to everybody? That is the effect of internal hinge. That is the effect of internal hinge. A structure can have in any shape. A structure can have in any shape if you know these two things, this one and this one. Then you can calculate very easily. You have to add. You have to add. For member hinge, you have to add 4. In case of plane, in case of space, 9. If joint type of hinge is there, then simply add m dash minus 1. What is m dash? M dash is the number of members meeting at that joint. Okay, if it is in case of space, then simply 3 times of that. 3 times of m dash minus 1. Okay, it's very simple. It's very simple. Now the last one thing is force release. Any doubt? Anybody? So the next is effect of which one? Force release. It can be in this shape. This one. It can be release can be this type of arrangement can be there. Okay. Another can be this is joint 1 joint, 2 joint, joint 1, joint 1, joint 2, joint number 1, joint number 2. It can be joint 1, joint 2. So in between the member, if in between the member we have such type of arrangement, then that are called as force release, and it has also additional degree of freedom. होगा नहीं होगा? It will have additional degree of freedom. What is this? This one. What is this? This is simply in this form. It can be understood in this form. This one. As it. Okay. This one. First one thing is like this. Here. It can free to move in linear direction. Get you ready? It can free to move in linear direction. One more movement can also be possible. This linear and another is rotate हो सकता है क्या? It can be simply rotatable. Rotation can also be there. So first one is this, another is rotation. So total degree of freedom for this type of arrangement कितना होगा? How much? It will be 2. Okay. Total degree of freedom for such type of arrangement, it will be 2. So degree of freedom, this one linear and rotational, and it is number 2. One rotational and another is linear. You can write as delta x, you can write as theta. Get everybody? Can you tell me What will be the degree of freedom for this case? What will be the degree of freedom for that case? 1. And which one is that? Only linear. At this time, that type of thing cannot be possible because state member has been connected. State member has been connected, therefore it will have only delta x and degree of freedom will be only 1. Okay. Here ये ऐसा है, ये दिस वन है ना, only 1. So and it is right. So its effect is to increase the degree of freedom. Kinematic indeterminacy. Okay. Now calculate. Suppose this type of structure has been given to you. This one. Suppose this is the case. So calculate the kinematic indeterminacy for such type of frame. For such type of frame. For such type of frame. Since this is frame, so every free joint can have 3 degree of freedom. So total number of joint, calculate total number of joint. How many joints it has? 1, 2, 3, 4, 5, 6. Total number of joint 6. Joint number 1, 2, 3, 4, 5, 6. Come to the. This is provided in between, okay, in between the member. That's why joint will not be treated. Okay, that joint will not be treated because you will take additional degree of freedom for that case. You will take additional degree of freedom for that. 2 degree of freedom you will take. Additional degree of freedom you will take 2. Clear to everybody? Therefore, why you are considered? What is need to count that joint? Is there any need to count that joint? Yes. This one is a different. It's a joint. In case of joint, it is simply m dash minus 1 additional degree of freedom you have to apply. Additional degree of freedom. Here, to calculate the degree of freedom, in that case, number of joint, how many number of joint is that? 1, 2, 3 only. We have considered only 3 joint. Okay, not this as joint number. Additional joint has not been taken here. Okay, additional joint has not been taken here in calculation of degree of freedom. In calculation of degree of freedom, additional joint has not been considered here. In case of internal hinge in between the member, since it is in between now, if it is at the joint, then no problem. At the joint you have to consider. consider, you have to count. At the joint you have to count, but in between the member you do not have to count. Kept in your mind. It should be kept in your mind. At the joint you have to consider, but here you do not need to. You do not need to have. And what is why here we have to consider? It's very simple also. It's very simple also. Because joint that joint has to be considered. That joint has to be considered. Means this is number 1, 2, 3, 4, 5, 6, 7, 8. Now I am explaining why that joint has to be considered. It is because joint number 5 is also free to move in any 3 direction. Is also free to move in any 3 direction. Get everybody? Is also free to move in any 3 direction, and okay, and rotation can also be possible with respect to any one leg. With respect to any one leg. Therefore, both things will be incorporated here. Both things will be incorporated here. Okay. Get everybody? So number of joint will be 6 here. Whatever, if you are calculating the degree of freedom by this method, there may be many methods to calculate the degree of freedom. In many books you can also find that they are considering this as a joint. It may also be possible. It may also be possible. In many books that can also be treated as a joint, but the procedure will be different. But the calculation for the kinematic indeterminacy, procedure for the calculation of the kinematic indeterminacy, that will be different. But the answer will be same. Okay. So number of joint is 6. So total degree of freedom, if all joints are free. Okay. Total degree of freedom if all joints are free. So how much total degree of freedom? It will be 6 multiplied by 3, total 18. Number of restraints, how much? 3 here, 3 here, 2 here, 3 plus 3 plus 2, 3 plus 3 plus 2, how much? 8. Okay. And apart from that, release. Okay. So additional degree of freedom, how much is that? Anna, it is 2, because this type of thing can be possible. Anna, either rotational, this one. So it is 2. What is final? So final degree of freedom, and final degree of freedom is what? Kinematic indeterminacy, and this value is 18 minus 8 plus 2. It is 12. It is 12. Clear? Now, if in this question all members are inextensible, if all members are inextensible, means that condition is also applicable. Which one? This one, number 3. If in question it has also been given, if in the question it has also been given that members are inextensible, that degree of freedom, kinematic indeterminacy has been calculated without considering the inextensibility. Okay, if inextensibility has been considered, yesterday I have told you what is the meaning of inextensibility. Inextensibility means length of member will not change after the application of the load. And what is the effect? What will be that effect? माइनस कर दिया जाएगा. नंबर ऑफ मेंबर्स, हाउ मेनी नंबर ऑफ मेंबर इज हियर, आर हियर? 1 2 3 4 5 and 6. 6 number of members are here. That everybody? Total number of members here 1 2 3 4 5 6. So if members are inextensible, then degree of freedom, final degree of freedom will be how much? 12 minus 6. Remaining will be 6. So नीचे नोट करके लिख लीजिए. If members are inextensible, note down. If members are inextensible, then final kinematic indeterminacy will be इस तरीके inextensible. It will be 12 minus 6 equals to 6. Okay. In exams, if information regarding the members has not been given to you, then you have to calculate only this one. That everybody. If information has been given for the member, then proceed for the next step. That everybody. Now, before going to complete this lecture, I would like to formalize how to calculate the degree of kinematic indeterminacy. Now at this level I can formalize, and its formulation is very simple. How? What will be the formula for degree of freedom? So kinematic indeterminacy dk, it will be degree of freedom per joint into number of joint. Okay, minus restraint. Suppose this is capital R, so you have to subtract by amount minus R, right? If this is M, number of inextensible member, okay, so minus M, number of internal hinge, so I am writing it as R1. If it is R2, that everybody, what is the effect of internal hinge and force release? They are increasing the kinematic indeterminacy. If I am writing R1 plus R2 as R dash, if I am writing R1 plus R2 as R dash, total additional degree of freedom due to internal hinge and force release, additional degree of freedom. R dash is what? Additional degree of freedom due to internal hinge and force release. Okay, so it will be plus R dash. So that can be the expression. That can be the expression. So that can be the expression. Now can you tell me the kinematic indeterminacy of this structure? Find kinematic indeterminacy of this structure. We have to find the kinematic indeterminacy of this structure. We have completed each and everything regarding kinematic indeterminacy. We have completed everything. And finally we have that expression. It's very simple. Number of joint multiplied by the degree of freedom per joint multiplied by the number of joint minus R. R is what? Restraint. M is if the members are number of members inextensible. R dash additional degree of freedom. Count number of joint. Number of joint. Okay. 1, 2, 3, 4, 5, 6, 7, 8. What are those? What is that? It is joint, and this one is member. That should be that should be differentiated to all of you. This is the member, this is the joint. Okay, in joint you have to take the node number. Here you do not have to take the node number. There should not be any confusion. There should not be any confusion. That's why I have taken example having both joint as well as member. So number of joint here it will be 7 and degree of freedom per joint 8. Okay, 8 and degree of freedom per joint. Since this is a case of frame, so frame has 3 planar and it is also planar. Okay, number of restraints. This one number of restraint 2 here, 3 here, 3 here. So it is 2 plus 3 plus 3. Total is 8. Clear? Inextensible number of inextensible member that has not been given here. So we will take it as a 0. M equals to number of inextensible member. Inextensible member. If it is not given, take it as 0. Right, everybody? Value of R dash. R dash is additional degree of freedom. Right, everybody? It is the additional degree of freedom. Additional degree of freedom here. It is member. How many? 4 additional here. Here. M dash minus 1. And M dash minus 1. What will be the value of M dash? 4. Number of members connecting at that joint. How many members are connecting? 1, 2, 3, 4. So it will be 4 minus 1 means 3. So additional degree of freedom is how much? 4 plus 3. So 4 plus 3 means it is 7. So put that value in this expression. What will be that? This one 3 multiplied by 8 minus 8 minus 0. No need to write 0 plus 7. What is that? 24 minus 8 plus 7, 23. This is the value of kinematic indeterminacy. This is the value of kinematic indeterminacy, 23. Right, everybody? If in the question, note करके लिख लें. If members are inextensible, inextensible, then what will be that value? What will be the value of kinematic indeterminacy? Okay, value of dk. If members are inextensible, how many? 23 minus number of member. Count the number of member. 1, 2, 3, 4, 5, 6, 7, 8 and 9. How much? Okay. Okay. Thank you for today. That completes the kinematic indeterminacy. Okay. Thank you.